imagine reality not as, a collection of static things, but more like an infinite jazz ensemble. Nobody holds a single note forever, right? Each line rises, listens, leans in, lands, and then it's gone. What's left is the chart, maybe, that the next chorus reads from. That image really sets the stage, doesn't it? It's a pretty vivid way to start thinking about the ideas of Alfred North Whitehead.
It really is. Yeah, we're diving deep today into Whitehead, a brilliant mathematician, of course, co-authored Principia Mathematica with Bertrand Russell, which people might know. But then, and this is the fascinating part, his thinking took this huge turn, and he essentially, rebooted metaphysics. He just looked at this century, focused on fixed objects, on things, and basically said, you're staring at the wrong thing entirely.
Ah, okay.
For him, reality isn't made of solid stuff. It's not particles in the way we usually think of them. It's made of happenings, of constant process.
Yeah.
It's not about being, but always about becoming.
Right, becoming. So our mission here for this deep dive is to really unpack these happenings, these things he called actual occasions, and then explore how his ideas, especially when we look at them through this lens called motion theory, how they still really connect with fields like neuroscience, even AI today.
Exactly. That's the plan.
Okay, so to really get a grip on this universe of happenings, we need to zoom in on Whitehead's basic building block, the actual occasion. What exactly is that?
Okay, so actual occasion, at its core, it's like a tiny, fleeting pulse of experience, just a flicker. Think of it maybe like a wave cresting for just a moment that takes in everything around it, integrates it, and then it perishes. It's gone. But it leaves behind a kind of pattern, a ripple, that influences the next wave, the next occasion.
Okay, so not a permanent thing at all, a dynamic event.
Precisely.
Yeah.
And motion theory translates this idea, the actual occasion, into what it calls a finite motion event. You could picture it almost like a loop that forms very briefly, grabs inputs, processes them, and then resolves itself.
A loop, okay. That helps visualize it. So there's a kind of cycle to these occasions, like how reality ticks at this super fundamental level. What's the sequence?
Yeah, there's a general flow, usually thought of in about 5 stages. First, there's initiation. A little local spark of activity starts up, could be a neuron fluctuating, or maybe just an idea starting to form in your mind.
Just the very beginning, okay.
Then it moves into prehension. This is really key. The occasion samples its neighborhood.
Yeah.
It's drawing in influences from everything relevant around it, physical forces, biological signals, social cues, memories. It's taking account of prior occasions, sort of gathering data, but also valuing it, weighing it.
Okay, so it starts, then it sort of senses or feels its environment and its past. What happens when all those influences are coming in? Seems like it could get messy.
Well, that leads to the next stage, concrescence. This is the critical bit where all those potentially competing influences get phased together. They integrate into a single coherent act or outcome. Think about, I don't know, all the different sounds in a room suddenly resolving into you recognizing a specific voice, or competing desires resolving into a single decision. Whitehead said this is where conflict becomes commitment. It settles into one definite outcome.
Conflict becomes commitment. I like that. Okay, so it integrates, resolves. Then what?
Then comes satisfaction. That's the moment the act is complete, its unique pattern is fully formed, it has achieved its specific definition for that moment.
And then the really interesting part you mentioned, perishing.
Right. The episode, the occasion itself, ends. It ceases to be an act of becoming. But, and this is crucial, it doesn't just vanish without a trace. It leaves that trace, that pattern or echo, which becomes part of the environment that new subsequent occasions can then prehend. They feel its influence.
So it's this continuous chain, this flow. Each ending feeds the next beginning. But hang on, if everything is constantly perishing, how do we get anything that lasts? Like a rock, or even my sense of self. How does identity persist?
That's the million-dollar question, isn't it? And motion theory gives a really interesting perspective here. Identity, in this view, isn't some static core. It's actually the habit of repeating a successful loop. Things endure because the pattern gets passed along, gets repeated.
Which brings us to Whitehead's societies of occasions, right? That's how he explains endurance.
Exactly. The whirlpool analogy is perfect. You look at a whirlpool in a river. Every single water molecule is flowing through it, changing constantly. None stay put. But the shape, the whirlpool itself, persists.
Yeah.
That pattern endures. That persistence is what Whitehead means by order. It's order as motion.
Okay, I see that. So it's not about the stuff, but the pattern of movement.
Precisely. And you see these societies everywhere once you start looking for them. A stone, its atoms vibrate, things change, But the overall structure, the stoneness, persists because of the inherited pattern of atomic bonds. A living cell, a storm system, even a language. They aren't static things. They're all dynamic patterns, societies of occasions, where the members inherit and reinforce a characteristic way of being, a specific order.
You could probably point to examples in physics like crystal lattices or resonant modes in system.
Absolutely. Crystal lattices are a great example. And in biology, tissues, or those neural assemblies we mentioned, groups of neurons firing together, they form societies stabilized by feedback loops. Even in culture, think about rituals, laws, even memes. They're like phase patterns that recruit new occasions, new people, new instances, maintaining their form even as the individual components change.
So from that motion theory angle, durable things are basically synchronized habits.
That's a great way to put it. Synchronized habits, patterns of activity that manage to repeat themselves.
Okay, that covers endurance. Now, what about these eternal objects Whitehead talks about? Things like redness or circularity. That term, eternal objects, sounds a bit, well, mystical. Like platonic forms floating out there somewhere.
Right, and that's a common hurdle.
Yeah.
It's really important to clarify, he did not mean platonic ghosts or forms existing in some separate ideal realm. That's not it at all. Think of them more as option sets, potential patterns, reusable shapes of order, or maybe preferred solutions that just happen to fit the constraints of how reality works. Like redness is a potential way light can interact with surfaces in our eyes. Circularity is a potential geometric form.
So they're possibilities, potentials that occasions can select or actualize.
Exactly. An occasion becomes what it is by selecting from these available possibilities, these potential patterns. And that selection is influenced, pressured by the past occasions it prehends, and also guided by its own internal aim, its drive towards achieving a definite outcome. This selection from possibilities is what gives the world structure and direction, rather than just being pure chaos.
That clears it up quite a bit. Okay, let's look back to prehension, how an occasion takes in its environment. You mentioned it relates to how we perceive things. Whitehead talked about causal feeling and conceptual prehension.
Yes, causal feeling is that direct, visceral sense of the past flowing into and influencing the present. It's the physical push of the world. Conceptual prehension is more about anticipation, abstraction, considering possibilities, what could be. And motion theory provides a really concrete parallel here. It sees perception fundamentally as a sync operation.
A sync operation. How so?
Well, think about vision. Your retinal oscillations, the firing rhythms in your eye, literally have to synchronize to lock onto the rhythms of the incoming light for you to see coherently. Or higher up in the brain, cortical assemblies, groups of neurons, synchronize their firing to bind features together into a perceived object, and they're constantly trying to predict what sensory input comes next based on past patterns.
So attention, is that like controlling the sync, deciding which rhythms to lock onto?
Essentially, yes. Attention, in this framework, is like prehension control. It's the process of modulating which prehensions, which incoming influences or potential patterns, are amplified or attenuated, which data the loop prioritizes.
Wow. Okay, this also completely reframes causality, doesn't it? It's not the old billiard ball model, A hits B, B hits C.
Not at all. It's much more subtle. It's about that inherited pattern pressure we talked about. An occasion's final outcome, its satisfaction, is a complex function. It depends on the weights it assigns to the various prior occasions it prehends, the salience or relevance of the available eternal objects or patterns, and its own internal aim towards coherence.
Motion theory calls this.
Resolution under constraints. It's finding a stable state given all the pushes and pulls. So cause isn't a simple push. It's more like the bias that past rhythms exert on a forming rhythm. And freedom, or creativity in this picture, it's that little bit of wiggle room, the sliver of creative recomposition that's left over after all those constraints have been accounted for. It's not absolute freedom, but it's not pure determinism either.
That's a really nuanced view, and this perspective extends even to space and time. Whitehead argued geometry isn't like a fixed box everything happens in, but it's somehow derived from the relationships between occasions. How does that work?
Yeah, that's another radical idea. Motion theory totally runs with this. It suggests that space-time isn't a pre-existing stage. It's more like the bookkeeping of synchronization across networks of events, where you have strong, smooth, highly coherent synchronization between many occasions. Space-time looks smooth and continuous, like the Euclidean geometry we're used to. But where synchronization is weaker, sparser, or maybe uneven, then space-time might look discrete or grainy or curved.
So gravity, the curvature of space-time. That would be related to differences in synchronization.
Exactly. Curvature in this view could be interpreted as gradients in synchronization structure,
Hmm.
differences in how tightly or readily different parts of the event network can sync up with each other.
Mind-bending stuff. Okay, so stepping back a bit, why do you think Whitehead's ideas developed decades ago still hit home for scientists today? What makes them resonate now?
Well, several things, I think. First, his whole process-first approach just fits better with a lot of modern physics, which already thinks in terms of fields and events rather than static particles. He just generalized it to everything. Second, he gets rid of those hard dualisms, especially mind and matter.
Mm-hmm.
They aren't fundamentally different kinds of stuff. They're just different grades of process, maybe differing in the complexity and type of their prehensions.
Simpler processes, more complex processes, but all process.
Right. And third, he offers a way to think about emergence, how novelty arises, but with discipline. Creativity isn't just magic. He frames it as constraint-compatible novelty. New things emerge, yes, but they have to work within the existing rules and patterns. They have to lead to a stable outcome. And finally, his view of mathematics resonates. It's a powerful tool distilled from observing processes, not a direct description of reality itself.
And this is where motion theory comes in as an upgrade path, right? Taking the philosophy and making it more testable.
Precisely. Motion theory aims to add those measurable dimensions. We can talk about phase metrics, things like coherence, mutual information, cross-frequency coupling. These are actual numbers you can get from experiments, ways to quantify how synchronized different parts of a system are. This allows us to potentially quantify concrescence, that moment of becoming, by measuring these synchronization dynamics.
So you could actually measure becoming? That's pretty wild.
That's the goal. And we can use loop mechanics, mapping these occasions onto formal control loop models. That helps explain stability, why certain patterns persist, but also how systems can suddenly shift or bifurcate, how resonance works in these societies of events. And it points toward building computational models differently, using event computing frameworks like Petri nets or process algebras, where the events, the happenings, are the fundamental building blocks, not static states.
Okay, so let's make it concrete. Where are these ideas, maybe enhanced by motion theory, actually showing up in today's science? You mentioned neuroscience.
Oh, definitely. Neuroscientists talk about neural assemblies, groups of neurons firing in sync, concressing into unified percepts or thoughts. That moment you recognize a face or grasp an idea involves a rapid synchronization across different brain areas. Key metrics they study, like metastability, the brain shifting between different coordinated states, and phase locking, brainwaves syncing up, fit this picture perfectly. Memory, in this view, isn't pulling a file from a drive, it's inherited pattern pressure, how past patterns of synchronization bias current brain activity. And attention is literally prehension tuning, the brain actively selecting which signals, which rhythms to amplify and synchronize with.
You can absolutely view ecosystems as societies of societies. You have populations interacting, nutrient cycles flowing, all dynamic processes. Those sudden regime shifts ecologists observe, like a clear lake suddenly becoming choked with algae, you could see those as concrescence failures. The previously stable pattern of synchronization breaks down, and the system flips to a new, sometimes less desirable stable pattern. And quantum foundations, you mentioned that earlier.
Yes, the idea of the actual occasion really resonates with some interpretations of quantum mechanics, particularly the event-based or transactional interpretations. In this view, a quantum measurement isn't just passively observing a pre-existing state. It's an interaction, an actual occasion reaching satisfaction, a moment where possibilities resolve into a definite outcome, a high coherence event that then perishes into a stable record.
Fascinating, and complexity science in general.
It's a natural fit. Complexity science studies how large-scale order emerges from the interactions of many small components. Whitehead's framework describes exactly that. Macro order appears when the micro-prehensions of many individual occasions align and synchronize. Those phase transitions complex systems undergo, like water freezing, can be seen as moments of collective creativity, where the system finds a new, stable way to organize itself.
And this isn't just theorizing. You mentioned testable sketches. People are actually trying to design experiments based on this.
Yes, that's the exciting part, moving from philosophy to the lab bench. For example, the idea of a concrescence index. Imagine researchers monitoring a network of neurons in a dish, or even coupled oscillators. They could use phase coherence metrics to try and predict the exact moment the network settles into a specific decision or pattern, literally measuring the spike in coherence that signifies satisfaction.
Observing the decision point in real time, that's powerful. What about that society persistence law?
Right. So take any repeating pattern, maybe a specific brain rhythm associated with a task, or a cycle in gene expression. The hypothesis would be that the duration that pattern persists is related to its internal coherence, how tightly synced its parts are, and its resonance with its environment, how well it fits with external rhythms or demands. You could then experimentally tweak those factors, maybe disrupt the internal coherence or change the environmental cues and test if the pattern breaks down sooner, exactly as predicted. It's about quantifying stability.
And prehension gating, inattention.
Yeah, there are already studies showing things like this. The phase of your brainwaves, just before a faint visual stimulus appears, can predict whether you'll actually consciously perceive it or not. So the experiment could be actively manipulate that pre-stimulus phase using brain stimulation techniques. If Whitehead via motion theory is right, scrambling that preparatory alignment should make you worse at perceiving the stimulus. It's like messing with the prehension window.
Trying to give Whitehead measurable respect, as you put it.
Exactly. These are ways to see if the conceptual framework actually predicts observable phenomena.
This whole approach really stands in contrast to traditional mechanism, doesn't it? The old view is list the parts, list the forces, calculate the results.
It does. Mechanism works really well for predictable systems, no doubt. But it struggles when genuine novelty emerges, when the system does something truly unexpected. Whitehead basically says, well, yeah, because the parts themselves aren't fundamental. They're historical habits, stabilized patterns of process. Novelty isn't the exception. It's baked into reality. The universe constantly composes itself, integrating newness. And motion theory echoes this in physics. Maybe forces aren't fundamental entities, but names for synchronization gradients. Maybe particles aren't tiny bits of stuff, but names for durable event societies, persistent loops of activity.
That has massive implications for how we might build artificial intelligence, too.
Huge. Imagine AI agents that don't rely on static, pre-programmed world models. Instead, they operate on incoming event streams. Their actions aren't calculated outputs from a fixed model, but concrescences, dynamic integrations of their current sensory prehensions, their goals, their aim, and their past experiences.
So memory wouldn't be like RAM or a hard drive.
Less like storage, more like pressure. The influence of past events, weighted by relevance and success, biasing the probabilities of current and future concrescences. It sounds a lot like meta-learning, actually learning how to learn and adapt based on past process.
And creativity in AI.
It could be framed as controlled divergence. You'd want the AI to explore novel patterns, to try new ways of combining possibilities, but always constrained by the need to maintain overall coherence and achieve a stable, functional outcome. It's like Whitehead's creativity, but disciplined by the physics of stable loops.
Okay, before we wrap up, it feels important to address potential misreadings. These are deep ideas, easy to misunderstand. Like hearing process and thinking it just means anything goes, total chaos.
Right, and that's definitely not it. As we discussed, constraints compose. Creativity is possible, yes, but it's only legal, only sticks, if it leads to a coherent act, a stable satisfaction that fits within the broader context. It's ordered novelty, not random flux.
And the eternal objects, we need to stress again, these are not mystical platonic ghosts.
Absolutely not. They are best understood as those recurrent fit forms, the potential patterns or structures that the universe seems to prefer because they work. They allow for stable complexity within the existing constraints. Think of them as the available grammar of reality.
And finally, that idea of experience at every level. This one seems particularly prone to misinterpretation, like thinking Whitehead meant rocks have consciousness like humans do.
Yeah, that's a big one. His term experience or feeling at the fundamental level of an actual occasion is minimal. It means a basic feeling of influence, a fundamental causal sensitivity, the bare fact that one occasion takes account of others in its formation. It's the bedrock of causality, not consciousness in any sense we typically use the word. Human consciousness is an incredibly complex, high-level societies of occasions.
Okay, good to clarify. So wrapping this all up, the final verdict seems to be that Whitehead had this really courageous insight, maybe ahead of its time, saying loud and clear, there are no permanent things, only acts that endure by repeating. Reality, seen this way, is, well, structured synchronization. It really does make you want to rethink how you view almost everything.
He absolutely gave us a powerful grammar of becoming. And now, the work, like with motion theory, is about trying to build instruments for that grammar, to measure coherence, model the loops, test the persistence, see if this beautiful philosophical structure holds up under experimental scrutiny.
Which leaves us with a thought for you, the listener. What if really internalizing this view, seeing the world as dynamic, flowing processes rather than a collection of static objects, What if that's actually key to building more resilient systems? More adaptable minds, maybe more flexible cities, more insightful science? How does shifting your own perspective to focus on process, on becoming, change what you pay attention to day in your own experience and in the world?
It's like that jazz ensemble we started with. Whitehead wrote the deep theory, the chart, guiding reality's improvisation. And maybe motion theory and related work are trying to write down the engineering notes on its rhythm, its syncopation, its structure.